Look at example 4. It says to describe how to transform the graph of f of x equals 2 to the x into the graph of the given functions. So we're starting out with f of x equals 2 to the x. What is that plus 1 going to do to our graph? Now, is it a horizontal or vertical? Horizontal, because it's with the x. Is it a stretch or compression, or is it a shift? Shift, because it's being added or subtracted. And it's a plus 1, so which way is it going to shift? Left 1. So we know that our parent function, if it's f of x equals 2 to the x, it's going to look something like this with our horizontal asymptote. Now for the parent function, what is this point right there? That's the initial value, which is what? 0, 1. But we're going to go to the left 1, you said. So now my graph is going to move left 1. And so this initial value now is over here. And where's that at? Yeah, negative 1, 1. Because the x value, the 0, went to the left 1, okay? So it's at negative 1. And so you might want to label these so you remember which is which. Alright, what about B? What is that negative going to do up in the exponent? It's going to flip it, so it's a reflection across which axis? The y-axis. Yeah, because x's are going to change signs. So remember, x's are positive over here, and they're negative over here, so it's going to cross the y-axis to do that. Alright, so my 2 to the x, so it's going to look like this. And so this one, just look guys, if I reflect this across the x-axis, the y-axis, it's going to come up like this. And if I reflect this piece across the y-axis, it's going to come down like this, isn't it? So did that point change? No, that initial point did not change. Alright, and what about C? What is that 4 going to do to the graph? Is it horizontal or vertical? Vertical, because it's not up with the x. Is it a stretch compression or is it a shift? It's being multiplied, so it's either a stretch or compression. If it's being multiplied by 4 and it's vertical, what is it? Good. So it's a vertical stretch by 4. Alright, so I'm going to draw in my parent one, the y equals 2 to the x. So now it's going to stretch my graph. What's going to happen? This is kind of the tough one. So it's just going to go up quicker. Alright, and think about it. That says 4 times. That means we would multiply our y's by 4, right? So if I took my initial value here and I multiplied it by 4, we would get the value up here. And so that's using our transformations to help us graph. Now, a lot of times when we did it, remember we used the parent table? My parent table will change every time my base changes, okay? So there's not just one, like with x squared, we said it was -2 to +2, and these were the numbers that went in it. We can't do that with exponentials, because if I have a base like this one, which is 2 to the x, I mean, just looking at 0, 1, and 2, that would be what? 1, 2, and 4. But if it was 3 to the x, using the same x values, now it's 1, 3, and 9. So our table changes based on what our base is going to be. So there's no particular table when we go to graph these.